Hi, hello, and welcome, ladies and gentlemen. And this is a big hi from the wonderful Meistersaal here in Berlin, where we are hybrid. That is moderators on stage, some panelists on stage, and everybody else digital in this event. And of course, it's day 3 of the Aero Days 2020, day 2 of the forum. And again, just like yesterday, completely filled with deep dives into diverse issues. Again, we're going to have 3 fascinating panel discussions, and you know more about that, Oli.
Thank you, Connie. Well, the first panel will deal with one of the magic words you currently hear, we all currently hear in any aviation congress all over the world. It's digitalisation, or to be more precise, the title and the headline of the panel starting in a few minutes is Digital Solutions for Automated Air Traffic Management. And this will be followed at 10:45 by the panel Urban Air Mobility. And this is really hot stuff in the general public. When you go to Google, with this term, urban air mobility, you will find almost 90 million articles. And then, Connie, we will nearly reach the finishing line with our last panel, which, when I look at the title, I think will deliver every answer we were looking for.
Well, I think everybody would be happy if we had the absolute answers by then. Now, visions of the future of aviation, of course, it's not just the one vision, but everybody else is chipping in. The most important thing is that there is one. Only if you know where you want to go, can you go in a straight line or fly in a straight line. And I'm quite sure that the European Vision Flight Path 2050 is going to be part and parcels of it. And of course, several other opinions. And that's actually one of the signature aspects of this event, the plethora of opinions, the plethora of pathways.
Well, I think a very important term the last days was also the term of cooperation. Well, the companies are competing with each other, but the need for cooperation, it was obvious in this Congress. Grazia Vittadini yesterday said during a panel, nobody can manage these challenges alone. And I think this was a common thread the days in this Congress. And, but also, I really do love it when engineers and scientists share their enthusiasm about aviation aside a PowerPoint presentation, but just with sentences like, without dreaming, there's no process. This came from Ivo Boscorol yesterday, and it shows to me, Connie, those ladies and those folks, they really love what they do, and I think that's great.
That's wonderful, and they're actually quite good with words as well, as you've just sort of pointed out. Alliterations of this Aero Days 2020, collaboration, co-opetition, cooperation, and co-creation. And then there are also some seductive elements, like, for example, yesterday we heard from Rolls-Royce that one of the need to sell it to the public is to make it irresistible to the market. Now, I think the one thing that unites each and everyone who is watching and who is partaking in these Aero Days is the fact that flying as such is irresistible to the human soul, and it's a question of how we make it happen, how we continue doing it in balance with this Earth's needs.
Well, I think that's a great sentence to start with the program of today. So let's get started with the first panel. So, welcome again to our first panel now, the first panel of the day, Automated Air Traffic Management. We know airspace is complex, and the way we manage it requires skill and judgment. It takes around 3 years to train as an air traffic controller. The reason the human brain is so good at problem solving in this environment is because it can process a lot of information, but more important, maybe it can also deal with ambiguity. A machine can manage a lot more of information, but ambiguity. How reliable digital solutions can be in a field where no mistake is allowed. I'm very much looking forward now to this panel and may introduce the panelists to you. My welcome goes to, from DLR, the director at AT1, Helmut Többen. Welcome from Frequentis in Vienna, the director European Affairs, Michael Holzbauer. From HungaroControl, the senior ATM advisor, Csaba Gergely. Welcome, I think he's with us by phone, the co-founder and chief financial officer at Unifly, Koen Meuleman. Welcome from Swiss International Airlines, the senior director business development, Jan Christian Schraven. And from the ADP Group at Paris Airport, Olivier, Delain. Welcome to you, gentlemen. And your session chair now is from SESAR Joint Undertaking, the Deputy Executive Director, Peter Hotham. Mr. Hotham, welcome to you all, and the floor is yours now.
Thank you very much, and welcome everybody to this event on digital solutions for ATM and looking at the digital transformation for our sector. And we hear an awful lot about digital. And I think the objective here today, certainly with this panel, is to give you some clear insight into what that really means. So some tangible things that can uncover what's behind this word digital. So in order to, before I hand over to our panelists, and they can do their introductions, I will have a short video that just sets the scene. So before we move to the panelists, we'll just play the video, enjoy the video for the next couple of minutes. Thank you.
Connections. Take to the sky and get from A to B quickly and safely. That has always been the vision of aviation. Now, smart, sustainable, and resilient are also part of that vision. The aviation landscape is also changing fast, starting with the aircraft itself. Soon, conventional aircraft will share the airspace with many other types of air vehicles, from drones and air taxis to electric, hydrogen, or supersonic aircraft, as well as those flying above commercial aircraft, such as balloons flying at higher altitude, or those used for environmental surveillance, or for bringing high-speed internet access to remote areas. Welcome to the new era of aviation. The transformation of the European sky to a digital one centers on technologies that can increase the levels of automation, share data in a cyber-secure manner, and increase connectivity in air traffic management. Since 2008, SESAR Joint Undertaking and its partners have been investing in disruptive technologies to deliver solutions which aim to make Europe's air traffic management system better able to respond to disruptions or changes in traffic demand, as well as reduce the impact of aviation on the environment. Some of the breakthrough innovations are an aviation data cloud, using digital solutions that enable information to be shared and kept up to date by all stakeholders, from airports to air traffic control centres to communication satellites and passenger smartphones. Artificial intelligence and data-driven tools that dynamically manage the airspace and scale up operations to meet traffic demands in real time. Low-cost, satellite-based technologies that enable precision landings at airports, reducing emissions and noise. Software-based technology that helps air traffic services to be more flexible, efficient, and resilient to disruptions by opening the system to innovation. Controllers can now serve any airspace, no matter where the physical control room is located. Technology that makes it possible for aircraft to fly in a V-shaped flight formation, mimicking the energy-saving techniques of migrating birds. Smart solutions offering passengers a seamless travel experience by allowing airports, no matter their size, to plug into the aviation network. And it is passengers, people, who are at the heart of this transformation. They are what drives the SESAR Joint Undertaking and its partners to build an integrated transport system, looking at the entire journey door to door, to offer the quickest, most affordable, reliable and greenest option. It is with this digital transformation that European airspace will become the most efficient, flexible and environmentally friendly sky to fly in the world. Smart, sustainable and resilient. A new era of sustainable travel thanks to SESAR and digitalisation.
Okay, so welcome back. I hope you enjoyed that. And I'd like to move through our panelists now, and starting with one of our key stakeholder representatives, the airspace user perspective, I'd like to hand over to Jan Christian Schraven. Jan, over to you.
Big hello from Zurich to Berlin and to everybody on the screen watching. Thank you, Peter, for handing over to me. I would like to set the scene a little bit and show you a few remarks, or give you a few remarks from the airspace user side, where we see the digitalization. Actually, I have been following up SESAR for quite a long time, being involved in the master planning process and in the master plan committee. So it would be good to see the next slide from my presentation. I can see it now. Okay. Well, then we start without the slides. Yeah, I've been working for quite a while in the aviation sector, and these are not the slides. No, right. Let's do it without the slides. Okay, I've been working for quite a while in the aviation sector, and I think what we are now encountering is something what we haven't seen before. I mean, my company, Swiss, we are just at a production level of about, yeah, sort of 20% of regular flying. I mean, we all know that this is unforeseen, unencountered, and actually we are not able to plan right now. I mean, we just try to be adaptable to cope with this situation. But we do, of course, think that travel levels will pick up, and we will see aviation coming back at kind of a speed, kind of a level we had before. Still, we don't know what all the effects of changes in human behavior will have on aviation, but it will pick up. So the challenges we had before, they are still existing. Wonderful. Yeah, here you see the production now we suffered in the last couple of years. Let's go to the challenges we had before, and they are still, yes, thank you very much. The challenges were, of course, punctuality. I mean, the red bars, they show the delay minutes we had in the last couple of years. They were all increasing. That was because of the infrastructure. It was not fit anymore for the amount of flights we had. We couldn't serve the passengers with right punctuality levels. So these challenges will come back. We do have old processes. We had old processes. I mean, we are talking data. We're not exchanging data like we do it at home or on the ground, but we are still talking data to the air. I mean, that is a very old process. And I know we are working hard to replace it, but it takes time. We are flying the detours. Yeah, we are flying the detours around. We're flying detours from point to point. We're flying detours by climbing up and climbing down. And that costs a lot of energy and it's not sustainable. But it's a challenge which is there since years, and it still is there. And of course, we saw it in the video. The new entrants which are coming, I mean, we do have it already here. We have encounters. We had encounters in the last couple of years here in Zurich. So there is a big challenge to manage it all together. And let me think about I mean, we have the ATM master plan from SESAR, we have flight press, we know what we have to do. It's all technology. I mean, the path is laid out until 2040 wonderfully. We know what we have to do. But I mean, from an airspace user perspective, we think we need speed. Yeah, we need to put it out in a speedy way and develop it and bring it to the aviation market, to the aviation reality. And that leads me to a point, because I've been responsible for several agile projects at Swiss. Yeah, well, and by managing these kind of projects, we learned that all these wonderful things, I call them social innovations, which social systems have done in the tech world. I mean, probably most of the panelists are using it, but all these social innovations, or self-organization, new work, partnering, a release train, OKRs, like objective and key results, they just help to dramatically speed up and the way and realize enormous results in a much shorter time. And it's probably a good way of managing to embrace the technology which is there around, or which is planned to be in the future. So I think besides the technology, we need to think about how do we manage to bring it alive. Because I think, and we from the airspace users, we think we don't have so much time. Yeah, situation, the challenges will come back, aviation will pick up. And then a very important point, and it has been already said in the beginning of the session or before the session, partnering. SESAR is a wonderful example, and I congratulate to that, bringing stakeholders from all sides together, and that's just understanding the different perspectives really helps. So partnering, I see, of course, is key, and we airspace users, we are involved, we need to be involved, and we will be involved. So in the end, to sum it up in the essence, I mean, the need for a scalable, resilient system remains. I mean, I talked about adaptability, and that even gives a key to have a scalable system, because we don't know how fast and the traffic levels come up. We know the road, but we, from the airspace user side, we look for fast implementation. So my question is, how can we use, and we probably should think about it later in the panel a little bit, the social innovations which are there around to speed up the process. Thank you very much.
Okay, thank you very much, Jan-Christian. And so important points there from the airspace user point of view. Just a reminder to all of those listening, if you want to submit questions for the speakers, please do so online, and we'll gather them together at the end and come back to our speakers. So thank you for that. For my next panelist, I'd like to move to airports and to introduce to you Olivier Delain from the Airport de Paris, and he'll talk about the airport and use of artificial intelligence. Thank you, Olivier.
Thank you very much. I will try to move to the next slide. I don't know if it works or not. It seems not. Sorry. Now it's quite difficult. Sorry. So next slide. So I will start by making a statement and a hope for aviation. A prediction that can be made with much confidence is that the entire industry will not be the same tomorrow as it was yesterday. However, we feel at airports that any crisis presents opportunities, and we think that the pandemic will accelerate trends to make airports more hospitable, smarter, environmentally friendly, and resilient. And innovation is the key. Yes. In those difficult times, innovation and digitalization are more than ever key factors to revive aviation in this industry. There are three, as an example, Groupe ADP, with the support of Île-de-France Regional Authority and Choose Paris Region, launched a Safe Travel Challenge call for application in April, with shared ambition of gradually re-establishing air traffic and restoring passenger confidence. And there were three major trends that emerged from the application pool, 300 applications from 31 countries. First of all, the application of new health standards. The second one is the monitoring and control of air quality inside terminals and contactless interfaces and services. In addition to that, I would like to go back to my previous slide, but I don't know what happens, but it's just to say that SESAR Joint Undertaking gave us the opportunity in SESAR 2020 to experiment post-COVID-19 recovery quick wins. And we propose to test the monitoring of some sanitary measures using 3D semantic cameras. Such technology combines a LiDAR 3D and a color camera. Full situation awareness is achieved or obtained through 3D localization, reality perception, and detection and tracking facilities. We installed 23 3D semantic cameras covering a surface of more than 4,000 meters square at Paris-Charles de Gaulle Terminal 2 in the baggage west area. The first step was to monitor passengers' flows, and a digital twin of the area has been built. And we associated some key performance indicators like debit, density measures, waiting time. The second part of the experiment that will happen in the Q1 2021 will be to monitor social distances, to monitor the temperature, so the associating our captors with thermic cameras and tracking people functionality, face mask detection, and identification of staff members. The second aspect that you probably see on the screen is the progressive and growing use of artificial intelligence at airports. Artificial intelligence has been around for more than 60 years, and it has gained ground more recently, essentially thanks to advances in computing and accesses to data. The aviation industry has started to explore the potential of machine learning algorithms on non-safety critical application. And there are a number of experiment implementation that are clearly oriented towards improving passenger experience. So you can see that on the screen. I will quote some of them: the deployment of humanoid robots to help passengers, like now at Tokyo Haneda Airport, Josie Pepper at Munich, Yep at Frankfurt, or Spencer at Amsterdam Airport. We have also some application for easing language difficulties, reduction of the stress, facilitating immigration without showing passport or scanning terms. We have also some application regarding biometrics and recently around turnaround. Artificial intelligence can be used to reduce the time that airplanes spend at the gate between flight. More than 30 experiments around the world are testing or installing such visual AI systems. You have a system that uses camera that points at the plane parked at the gate to track everything that happens after the aircraft lands. And the AI system can identify the elements on situation that most often cause delays so that managers can take actions. We set up an SESAR exercise with EUROCONTROL and Atos to validate whether machine learning and business intelligence could provide benefits at Paris-Orly. And we focused on 3 operational scenarios that address both landside and airside aspects. First of all, how the security and border control process can be improved to better prediction about what will happen. How the saturation of parking stands can be predicted with sufficient anticipation. And whether a prediction of the last passenger boarding could be obtained to alert about any delay. The results show that all of them were considered pertinent and useful. And we have 3 main lessons learned that were identified and that we shared with our community. The first of all is the need to qualify with airport operations staff a subset, stable in the long term, of operational reference data linked to each process. The second is the requirement to build up a learning environment. We have to achieve in a sliding window the last 2 years of airport dynamics for operational reference data. And the third word is more a conviction, the conviction that the best prediction models are those that ensure a computational propagation of operational constraint from the terminal process to an aeronautical area. Now, the result is that we investigate machine learning techniques at ADP to provide with adequate anticipation, prediction about connecting passengers, connecting times, prediction of taxi times, and prediction of aircraft readiness using flight progress milestones and learning from the past. Thank you very much.
Thank you very much, Olivier. So moving from airports now and to disruptive technologies for air traffic control, I'd just like to introduce Helmut Többen to talk to us about flight-centric. So Helmut, over to you.
Yeah, thank you, Peter. Good morning, everybody. I hope you can read me well. I also try to switch to the next slide. Okay, that works fine. I'm coming from the DLR Institute of Flight Guidance, and at the Institute we are developing strategies how to get from human-centered automation, which we did for the past years, to the vision of a fully automated ATM system. And this is going to be based on 3 pillars, which are future ATM concepts, like, for example, sectorless or flight-centric ATC, which I will say a few words on the next slide. Then, of course, new mobility, including drones, air taxis, and all these new vehicles coming into space. And then the third pillar is, of course, the more sustainable performance-based airport management, like we heard already earlier. This is all done by a major role in the development is also played by our validation infrastructure, which is quite big at DLR. So we have the validation infrastructures are ranging from simple fast time simulations up to full-scale flight tests and field tests at airports. So all this plays a role. So I would like to show 2 examples. One is the sectorless air traffic management that we developed at DLR together with DFS and speech recognition. So in the year 2008, we started with this sectorless development, and the reason was that the sectored airspace has 2 major disadvantages. One disadvantage is that we have a high difference in workload with all the sectored airspace. So normally there are some very crowded sectors around hubs, not in these times, but in normal times, and I hope we get back to them sooner or later. And there are other sectors where the workload is very low. And the second issue is if the traffic increases in one sector, the only chance to handle it is to split up the sectors into smaller ones. And everybody can think that this is not working unlimited time. So there is a natural limit of the traffic density that can be handled. So that brought us to the idea of the sectorless airspace, where one controller is controlling one or several, in this example, 6 aircraft, which are located geographically independent. So they are all over the larger sector or the sectorless airspace. This idea is not totally new, as it was used by militaries already. But as you can show on the right lower graphics, this can increase the efficiency by at least twice. So we did trials in the upper airspace where we could show that we can handle the same amount of traffic with half the amount of controllers. And so we are looking into this also in the SESAR program in the current Project 10. We are trying to further develop this concept. And that brings me to another example of using speech recognition. So even if we get more and more data links in air traffic management, voice will play an important role, and it has one major issue, and this is that it is not digitized yet. So if we try to digitize the airspace, all our tools need to know what was spoken between the air traffic controller and the pilots. And therefore, we implemented voice recognition. We do not develop the voice recognition engine by ourselves. We take state-of-the-art voice recognition engines from the research market. But what we do, we implement the context knowledge that we have from the ATM area to increase the recognition rate. And then this data can be used, for example, for pilot readback error detection, for modeling or foreseeing the pilots and the controllers' behavior, for pre-filling any electronic systems like flight scripts, radar labels, or whatever, and, for example, for estimating the pilots or the controllers' workload. And that finishes my talk.
Okay, thank you very much, Helmut. Very interesting. So what I'd like to do now is take us to another slightly disruptive as well approach, really around the virtual centers and being able to assign capacity on demand, something that's pretty relevant right now. If we had this, I think it would really be delivering some benefits. So introduce Michael Holzbauer, who will tell us about where we are with this this technology and this concept. So over to you, Michael.
Thank you, Peter, and also thank you to the my topic, talking about
Okay, so whilst we try to recover Michael back into the session, then he's back.
I'm back, sorry.
Okay, yep, he's back. So I'll hand back to Michael. Otherwise, we'll give that another try. Over to you, Michael.
Yeah, thank you. I'm back here. So digitalization is one of the key elements in SESAR actually, and one of the topics we are researching meanwhile since several years in there is the topic of a virtual center. A virtual center is a key technology for providing actually capacity on the places where it's needed, so capacity on demand. I'm right now trying to see my presentation somewhere. Okay, here it comes. We are now at the crossroads. We can decide now on whether to continue to invest into what we have today, into our legacy technology, into the status quo, or whether to invest into future technologies and concept of operations, into information-centric and open systems. Actually, we bring very good know-how from the legacy, and we now need to bridge this know-how into the future world, into future challenges with open concepts. One of them, virtual center. It's about information and infrastructure sharing, leading to getting access from anywhere to anywhere. So, I do not see my presentation moving. Okay, so I keep the presentation where it is. Virtual center has been described. Virtual center has been described in the airspace architecture study and also in the SESAR ATM master plan very nicely. And actually, it is about getting access. Actually, it's about getting access from any sensor data to any controller. And by that, and Helmut mentioned it already before, by that, a controller can manage any aircraft entering the large sector of pan-European environment. So the airspace architecture study describes very nicely the separation of ATM service provision and ATM technology, so ATM traffic service provision. This separation means that controllers would be independent of a geographical location in a situation to take on the management of airspace in a completely different European country. Let's think back a bit to this year, but also to some years back, where emergency events happened, like the fire breakout in Chicago center some years back, which led to grounding of more than 2,000 airplanes. And it took about 1 month to bring that center back up again. With handing over complete center functionality to another center in a cross-border environment, the contingency could happen more or less immediately just by handing over the control of that specific airspace. But also this year, during the corona pandemic, we've seen that the center had to be closed basically because of some of the controllers had been infected. So with virtual center technology, it would be possible to switch over the management of that specific airspace to any other center. So it is about controlling airspace from any place, from any other area control center. So, and that concludes my presentation for today. Thank you.
Okay, thank you very much, Michael. And then moving on to another virtualization, if you like, digital towers. And I'd like to introduce Csaba Gergely to present to us about digital towers. Over to you, Csaba.
Good morning, ladies and gentlemen. My name is Csaba Gergely from HungaroControl, working for more than 30 years as the tower controller. And I'm going to give you a short brief about the digitalization and further development direction of the tower airspace. First of all, you can see a nice background behind me, and with a short video, I will give you an introduction of this facility.
Hello, I'm Csaba Gergely from HungaroControl, working here for more than 32 years as an air traffic controller, and I was involved in the design and shaping of the remote tower facility, which is still the one and only design for medium-sized airport. We are here at the headquarter building, and now we are going to demonstrate you this cutting-edge technology. We are here at the HungaroControl's headquarter building. Let's go inside and take a look at our remote tower facility. So welcome to our digital tower facility, which is one and still the only designed and operational for medium-sized airport. Since 2016, we had more than 2,500 operational hours from this facility, and during the COVID crisis, we had a shared service provision between the concrete tower building and this digital tower. Our strategic program contained several parallel projects, like the initial design phase, the safety case, the human factor case. Further developments were driven by air traffic controllers' feedback and insights. So this facility contains 4 controller working positions, a supervisor position, and the matrix video wall which is a result of a mindful design. The video wall should cover the large area of the airport with multiple camera positions. Thanks to the distributed camera system, we can see every corner of the airport. Every controller working position has its individual hotspot cameras, and we can follow the traffic with dual sensor HD PTZ cameras. It has not only visual sensors, but infra sensors as well, which help us to follow the traffic during nighttime. Also, the video system is integrated with the ASM-GCS, so we can have automatic labeling. The labels appears not only the ASM-GCS pictures, but on the video wall as well. With this development, we successfully saved money, resources, and time. Also, we gathered information how to develop this installation with the latest technology. In the SESAR project, there is a promising direction of development, the multiple remote operations, where single air traffic controller can provide service for multiple airports simultaneously. We would be very happy to help you in your remote tower journey.
Thank you very much. And now, with a few slides, I give you a short briefing of this digital tower technology. First of all, I'd like to move for the next slide, please. So anyway, you can see HungaroControl has not only a remote tower, but a remote airspace as well. As you can see, two white spots on the map. The larger one is Hungary itself, and the smaller one is the airspace for Kosovo, where we provide air traffic service from Budapest. And if we get the next slide, can we get the next one, please? Yeah, this is one. One more further, please. Thank you. So you can see why we are talking about digital towers. In the last century, when I started my career as an air traffic controller, the more powerful weapon of the controller was a pen, with which we updated all the data on the paper strips. Since then, almost all the information sources, information, the data exchanges, the surveillance transfer to digital format like electronic fly strips, electronic fly lists. We introduced ASM-GCS systems to cover all the airport and provide all the surveillance data and transfer to several distributed users in digital formats. But the visual surveillance for an airport is still remained the good old sight with human eye. Using camera technology and change the surface of the glass window to a screen and the camera, we changed this technology and digitalized the direct side of the control. Once anything is digitalized, the location is absolutely independent of the data source. We can transfer the data for long distances and provide air traffic control from remote locations for airports in large. Can we move to the next slide, please? Once we have this technology in place and we have camera technology, there are several development directions which is seen on the horizon. Some of it we have heard centralized service provision for multiple airports, but still one controller controlling one airport. We are developing disruptive technologies for multiple remote operations, when a single controller can operate 3 airports, providing service from a single remote location using camera technology. On the other direction, and we have the experience and the knowledge of that. Having a contingency solution for major airports, for larger airports with a distributed camera system, providing service continuity. So these kind of developments are already in installations in major airports like Singapore, Changi, and other major airports where they don't have a solution for alternate airport. And that was my short introduction, just a briefing of this technology, and thank you very much for that.
Okay, so thank you very much there to Csaba, and I'd like to just move now to another form of airspace user, a new incoming user type, the U-Space and the ecosystem for unmanned flights. And I'd like to invite Koen Meuleman to tell us a bit about the U-Space. Koen, over to you.
Yeah, good morning, everybody. Unfortunately, I was not able to log in through the video system, so I'm only there through phone. I realized, or I was told, you see a nice picture of myself in the meantime, so it is great, I hope. Indeed, just a brief introduction on U-Space. I mentioned, I think you see my slides, I hope. The main slide is I mentioned the future ecosystem and deliberately put manned, unmanned, so unmanned between brackets, because we think it might be the future for both manned and unmanned. But I realize I'm the newcomer here and probably the underdog in this panel anyway. I will give you a few more words. Let's say I have a short introduction video of 1 minute, which I will guide you through. So the people, I don't know, I cannot see it, so you can move to the video from my side and start it. In the meantime, I will give some comments. So Unifly, I'm Koen Meuleman, one of the co-founders of Unifly. We are a software company based in Belgium. What we do is mainly developing UTM platforms. We are a software company founded in 2015, and we provide UTM solutions worldwide. What you see now on the screen is an integration of radar tracks into our system. And it started all back in 2014-15 when we went second at the swim masterclass. And you see some screenshots here. Today we are 60 people. We have offices in 3 countries, including the United States. And our system provides functionalities both for drone operators, pilots, and has functionalities such as pre-flight monitoring, authorization flows, validation against local rules, as well as real-time flight monitoring. That's what we see here. I think, yeah, okay, we see urban air mobility. I think you see it's broader. We focus on today's businesses and drone operators. But I think at the end, the goal for us is integration rather than segregation, which is currently being promoted. Yeah, I don't know if you could hear what I was telling, but anyway, I think, yeah, we provide UTM solutions for a bunch of clients already, and where we think integration is key rather than segregation, I would say, which is currently being promoted through regulatory initiatives whatsoever. We can move maybe to the next slide with the map. And that map shows that I would say UTM is already a kind of reality today, because what you see there are our current implementations of our system. So within Europe, we have Skies, DFS, Naviair, and HungaroControl, which are already using our system to a certain extent, and depending on where we are in their development. We are also busy in implementing our system in Finland. And the last and most and the biggest one is NAV Canada, where we were chosen by NAV Canada to roll out our UTM system on a national scale over there. But maybe a few words on our involvement then on within SGU, and we can go to the next slide, to the fourth slide. We have been contributing, let's say, over the past few years to more than a dozen SGU projects in the framework of USpace, of which Chorus might be probably the most famous one. Maybe many people might have heard of Chorus, which was the development. It was led by HungaroControl and consisted of the development of a CONOPS for USpace. But I would say the most complex one and the most difficult one, for me at least, it was SAPPHIRE, which was a huge demonstration project which happened last year. And I think the acronym says a lot. It was about the safe and flexible integration of initial use-based services in a real environment. And with that real environment, it was we meant the area of around the port and the airport and the city of Antwerp in Belgium. So with that hands-on experience and leading that large consortium where we demonstrated a lot of multiple use cases, we saw basically that a need of integration, of at least future integration between ATM and UTM is for us, I would say, mandatory. We had that initially installed. It was not really integration. Let's call it maybe information exchange at this stage. And that it's really important if you want to go further on the space with USpace and drones integration that ANSPs, CEAs, and all involved stakeholders like port authorities, cities, authorities are involved, because otherwise I think we will not make it. And maybe let's go to the last slide, let's say, which is the fifth slide, where you see basically a map of what has happened in the airspace which we were operating in. You see the yellow boundary, let's say, of the CTR of Antwerp, which we were flying in. In the north, you see the port area, which is a restricted airspace on its own. And then you see also the red line, which are, I would say, encountering or encircling the airport of Antwerp. And you see the landing path of the aircraft. So within that environment, I would say on a normal business day, we operated 9 drone scenarios, from observations, mapping, package delivery. So we had 90 kilometers of drone flights within that area, happening in controlled airspace, overlapping with another jurisdiction being the restricted area of the port of Antwerp. All flights were per definition BVLOS, and that all worked through, I would say, integration, at least communication, and involving all stakeholders. So my takeaway from this project, at least, is that we should go for integration and involvement of all stakeholders if you want USpace to make a success in the future. And this ends my presentation. Thank you.
Okay, thank you, Koen. So that takes us to the end of the panelists now, and I think we should come back and revisit now with some questions. So first of all, to Jan Christian, you talked about speedy, the need to be speedy. How do you think we could create that sustained speedy shift in the ATM mindset? You know, moving from capacity to sustainability was one thing, but now, thanks to COVID, also scalability and resilience. How do you think we can create that momentum? Yeah, Christian.
Yeah, I think, first of all, I mean, what we do already, and we always highlighted partnering and understanding the context of everybody who is involved and who participates in this aviation ecosystem would help a lot. And I think we can do more. And then honestly, I think we need probably to revise our mindset thinking and how we develop, how we bring new technologies live. Might be that we should make use more of the of experimentation in a controlled thing, to really get the understanding to the people. There are good solutions out there. We need to test them. It is safe, and we learn from it. So experimenting, testing, learning all together. I think these are the things. It sounds so simple, but bringing all the mindsets together is very important, I think.
Okay, yeah, thanks, Ian Christian. So partnering, experimenting, and learning. So if I go to the airport side of thing, Olivier, you also talked about the implementation of artificial intelligence, and there's quite a lot of debate around how that would really work in terms of how you achieve a human-like action when it's working within a largely human-centric system, and how you manage the ethical side of this when you go to implement. Have you got any thoughts on that yet from your work, Olivier?
Thank you very much for this very important, I would say, fundamental questions about ethics. And when I'm thinking about ethics, I'm always referring to Mr. Joseph Weizenbaum with his first conversational computer program, which was named ELISA. It was in 1966. And in 1976, he expressed apprehensions about AI, and he defended that computers shouldn't be allowed to judge, and said that if emotions and judgment become part of this process, then humans should intervene. So that means that since those debates are there since more than 45 years. And they are always continuing. And it's normal because, in fact, there is a proliferation of AI systems at the moment. And the main debates about ethics at the moment are about, for example, accountability, responsibility. You remember that in 2018, a pedestrian was killed by a SUV while crossing the road. And the car didn't recognize the figure as a pedestrian just because the pedestrian wasn't near a crosswalk. So who was liable for this? Another aspect is the privacy surveillance, manipulation of behavior, for instance, and opacity of AI systems. AI is also always felt as a black box. So people don't feel very comfortable when they don't understand the decision, why the decision is made. Another aspect is also automation and employment. So creation of new jobs against destruction of jobs. And finally, autonomous systems, because there are several notions of autonomy in the discussion. I think that there are two documents that are very, very important in that aspect, and that coordinates the rest. In fact, it's the document of high-level group from European Commission and guidelines on trustworthy artificial intelligence in 2019. It is articulated around four main principles: the respect for human autonomy, the prevention of harm, fairness, and explicability. And they also set a number of requirements, 7 requirements about accountability, technical robustness, oversight, privacy, data governance, non-discrimination, transparency, social and environmental well-being that must be addressed from the start. That means from the idea, when you have an idea about what AI should do, the use, the development, the deployment, everything should be addressed so that everything can be traced. And I think it is very important. And another very important document also is the EASA AI roadmap that was released in February 2020, which will go in the next years further than that by providing a kind of certified artificial intelligence. And they distinguish between 3 interactions. First of all, the level, what they call level 1, that it is assistance to human. Level 2, that it is human-machine collaboration. And the level 3 is the more autonomous machine. But human is in the loop at design and oversight time. So it is very, very important. So what I want to say about that is that AI faces multiple facets scientific, industrial, societal, and ethical. And those are very much interrelated. And last word, I would like also to insist on the training aspect, the staff competency. And I don't know if it is done in Europe, but I would encourage, in fact, in the engineers, pupils studying people in engineers to have a specific competence in ethics. Thank you very much.
Okay, thank you, Olivier. And I think you also mentioned in your answer there about the EASA and the approval to be able to operate these kinds of technologies. I think that's a very important point as well to put into your summary there, because we are in a regulated industry, so important to have EASA on board. So just moving on to another area of change, and I'd like to come to Helmut and ask about, you mentioned in your presentation about, you used those words, fully automatic, quite a controversial little sentence there. If you look at your flight-centric proposal, and if that's our ultimate objective, what do we need to do to actually ensure that this becomes a reality? And does that take us towards this fully automatic, you said, or is that something else? So Helmut, over to you. Thank you.
Yeah, what we of course would need is one can imagine that the controller needs to talk to all the aircraft which are even far away. We would need, of course, a geographically independent voice and data communication infrastructure. Unfortunately, I see Michael is maybe not online because Frequentis is very much involved in that. This could be, for example, LDAX or something similar. Then the second thing that we would need is a very accurate weather forecast, because the sectorless is also very much relying of planning tools. So the controllers need some support tools. There we are not in the area of full automation, but higher automation levels, because this sectorless control area, nowadays, with the sectors, the controllers have a very good situation awareness due to the fact that they have a spatial representation of the airspace and can handle the air traffic. With the switch to sectorless, this is also a further challenge for the controllers, because they must build their situation awareness in a completely different way, based on the system outcome and the proposed solutions that are coming from the system. Further on, we need tools or procedures for demand and capacity balancing and air traffic flow management in the flight-centric ATC. That still needs some research and development. And then I don't believe that we will switch from sectored airspace to a sectorless airspace immediately all over the world. So I believe that the sectorless will come from the upper airspace, where it's a bit easier down and further down. And so there is this complicated transition aspects between a flight-centric or a sectorless area and the still sectored area. So those 4 points, I would say, are the major challenges to come to a sectorless airspace.
Thanks, Helmut. You talked there about having sectorless in different regions of airspace, and by using the upper air, that's clearly not the highest density airspace, but we have this effect in the sectorized airspace where we suffer from this diminishing return. The more we sectorize and divide things up, the more interfacing and extra workload it starts to create. So what would you say about the high density airspace? Is this somewhere where sectorless could give us a return as long as we have these tools?
I would say yes, because with the sectorless airspace, if the traffic increases, you just add more controllers. I wouldn't say it's unlimited, of course, but you don't have to split up. You just add more controllers. And you can also add special train controllers for the wide variety of aircraft that we are expecting, like high-flying balloons, returning space traffic or starting space traffic or whatever, so, or drones, unmanned vehicles. So for all these different purposes, you could also have separate trained controllers. So just add more controllers, and you can more equally distribute the workload. Nowadays, you normally have some very crowded sectors and other sectors where there is less air traffic. And with the sectorless concept, you can equally distribute the workload on all the available controllers.
Okay, right. Thanks, Helmut. Which I think gives me quite a nice link actually to Michael, because we talk about more controllers distributing the workload, and Michael, you talked about the virtual centers being an approach to redistributing and dealing with scalability as well. But it also comes to my mind that by handing over and digitally connecting these different virtual centers, we're having to tackle very seriously the risk of safety and cybersecurity. And this word sovereignty comes up as well, doesn't it? And something that's come from our audience about tackling sovereignty. Do you think you could say something about the role of cybersecurity in the virtual centers, and maybe anything on sovereignty, Michael?
Yeah, thank you, Peter. I hope my connection works now better than before. Actually, when discussing virtual center technology or capacity on demand in operations, we realized that the challenges in that regards are quite similar to the challenges as we have actually today. So today we live already in a quite connected world. Today we have our area control centers. They are mostly built up on their own data centers. When talking about virtual center, it's just the next steps interconnecting those centers to each other, exchanging information via high performance ATM grade networks. So the challenges are basically the same. However, there are several dimensions we have to look at on. It's about people when we talk about cybersecurity and safety. So people need to be aware of what they're doing, how they are doing it. So I'm just reminding on the just culture here. Second point, it's about technology. So we are, as manufacturer and as all other manufacturers, I'm pretty sure on that, we are implementing measures already today that, for example, any backdoor things are closed and that the bad guys cannot sneak into our systems. Third point, it's about processes. So we need to make sure that any risk which might arise in a security environment are mitigated right from the beginning. And here I'd like to add here a bit on the point of sovereignty. Today, it's a very national view we are aiming for. If we talk about interconnected world in a pan-European environment where information exchange from sensor to controllers location independent, then we have to make sure that those processes are working location independent across organizations. And the fourth point I'd like to address here is about the regulatory or legal dimension. So the regulation needs to provide the right framework here, including a very clear description, the clarity, bringing clarity into who is responsible for what. which service is dealt by which organization, and where are the boundaries of those services so that it's clear where liability is.
Okay, thank you. Thanks, Michael. Do you think, just coming back to your point on connecting and dealing with the cybersecurity and this sort of thing, do you think there's something we can learn from other sectors outside of ATM? You know, this largely distributed system is not new outside of ATM. It's new to us, but where do you think we could learn something from other sectors?
Yeah, actually, one element in there, and we've seen it, for example, in the banking sector, is providing the right information to the right people. So whenever something happens, this information will have to be distributed more or less immediately to all other stakeholders which might be concerned in a security breach. So this is something we might be able to learn also from within ATM, within aviation, also from other sectors. Being open and exchanging information without any fear. So today, I have the feeling a bit that this kind of information exchange is still a bit delicate, meaning people do not want to tell others that they have been attacked. So this might be something we can learn from other domains.
Yes, good point, yes. And this focus on services really changes how we think about our technology and how we deliver it. So very good. If I move to Csaba, you talked about the digital tower. It's a completely new way of delivering a service. Traditionally sitting in a physical location on an airport, and you very well showed us that this is no longer needs to be the case. So you have something there that's working, and I see there's a number of deployments going on in Europe. There are business cases for it, for these digital towers, mostly on the quieter airports where there's some economic benefit as well. But if I look to the next step, where would you see this vision for digital towers? What does that future look like for the digital tower? Csaba.
Well, first of all, if you want to take a look into the future, you have to understand the past. And the installation you can see behind me, it is already history. It is already the past of this kind of technology development. And we are still working on the next edition for this remote tower for HungaroControl. However, in my experience, we are working in cooperation with other companies to develop other installations in the Far East, Singapore, for example, and a couple of NSPs in the Middle East as well. But in my opinion, these days only the initial steps for development of digital tower technology. The first steps, including digitalization of the visual surveillance, but the next, in the close future, not so far from now, there will be other technologies incorporated into these developments, like voice recognition, artificial intelligence, and already appeared several applications and add-ons to enhance the visual surveillance. So, in my opinion, the future will be further implementation and integration of other disruptive technologies and enhance air traffic controllers work, and further new supportive tools to develop and appear into airdrome. That's my expectation in the next 5 to 10 years. Despite this COVID situation slowed down processes a little bit, development is still the area where all the technology buyers can ability and the opportunity to develop and make more perfect and more mature their development.
Okay, thanks, Csaba. You just picking up on some of the things that you said there. Also in your presentation, you said about extensive use of cameras to create a visual image. Are you doing anything on bringing other forms of data into the system and having a big data fusion to enhance what the tower controllers can see beyond what they would see if they were physically in the tower? You know, I think you showed us that you're right now replicating what they would visually see, but how far are we going with big data and data fusion?
Well, of course, the first step is to modeling what the controllers can see from the tower right now. Later on, and if we are talking about larger airports, where the area to cover is larger, and if we want to take benefit of the camera technology, it is not sufficient to have the out-of-the-window view duplicated with the cameras, but we have to use distributed camera systems. We also developed at Budapest, and put into the controller's view several camera sites, so we can take controllers closer to action, give them more detailed visual information on remote distant areas of the airport, and also the source of other data can be integrated into the system. So system integration still will be the focus area of the future developments.
So we're bringing together multiple sources of data there and introducing things like tracking and labeling and bringing more rich forms of data to the controller. But just coming back again on the cybersecurity, the fact that the tower is now digitally connected and remote, it's a common theme that's coming from the questions from our audience about how again, in this area, we would be looking at and tackling the cybersecurity challenge. Do you have any view on that, Csaba?
Well, I'm an air traffic controller, so I don't have detailed information and knowledge of area. What I can assure that cybersecurity aspect almost same area what we do have in radar environment regarding radar stations and radar control centers.
Oh, I think we're losing you there.
So,
I think we're losing you there, Csaba. So I'll come back to you if you get a chance to reconnect. But what I'd like to do is move to Koen and talk about. You talked about U-Space, this whole new type of aviation in our system. And the question I really have for you is about how we address the challenges and what are those key challenges to making U-Space a reality. You said in your presentation, integration is a key, but could you go a bit further in that and have a look at and tell us a bit about perhaps the regulatory aspects and how you would want to speed up that implementation? So Koen, over to you.
Thank you. Thanks for the question. Maybe I want to make immediately a reference for if people remain with questions after what I will have commented, that SGU has published its consolidated report on all the projects which have happened recently. So you will have a lot of answers in there as well. But I think to bring U-Space to reality, there are, I would say, there are still some key challenges, and they are a bit different in nature. But on the other hand, I think if we go step by step, they are also realistic to be solved on quite a short time. I think first of all, to start with, that use space for me is really mandatory and is highly important for the drone market to emerge, especially when we think about BVLOS applications. I think because there is a lot of, I would say, potential in BVLOS applications with drones. I think there's where the real market will emerge. So to open that market, I think use space is mandatory, basically. On the other hand, I think if you turn it around, use space is a tool, or should be the tool for all stakeholders to guarantee the necessary safety and security which we all want. I think they both go hand in hand. It's the chicken and egg problem there. So I think use space is kind of mandatory if you want the drone market really to make it happen and to emerge. And then what are the challenges? I think there are both on the regulatory side and on the technological side are some challenges. From the technological point of view, I think we are per definition talking about a digital system. So I think in that sense, connectivity, and especially while we are talking with drones, which are not being seen on radars and on I would say, classical systems, connectivity is key. Yeah, we need to be able to see the drones into the system, or at least know where they are operating in which area. So connectivity is a challenge on its own because traditional, I would say, communication, traditional use in aviation won't make it. So we will have to rely probably on mobile networks or on private networks to have everything integrated. On top of that, when we develop and we deploy the use space, we should, and that's, I think it's still lacking, I will come to that we are dealing with other airspace units, which are today already there. And I think for use space, the threat doesn't and use space doesn't form a threat for classical aviation, but more for general aviation. I think about general aviation, emergency helicopters, police helicopters, military flights, and that's where the challenge is. We should get connected to those flights. Drones should get connected, that there is a mutual situational awareness. That's one major topic, I think, as a challenge. Further, out of our experience, I would say, in Antwerp, it sounds stupid, but it has been highlighted already by Eurocontrol in the past, something like an altitude reference, a common altitude reference. We, from the drone world, we are talking in GPS altitudes, which are not necessarily the altitude language used in aviation. So that are, for me, the key, basically, challenges which can be solved with good, I would say, with agreements, let's say. But these are key topics to be taken up and to be solved before really we can go into use space. On the how regulation can play a role into this, I think regulation is definitely an important facilitator to foster this market. But as I see the use space regulation evolving and what has happened over the last 2 years, or last 1 year, I think the regulation, the current draft, they should focus rather on the goals. What do we want to achieve? Where is the ultimate end goal of how does the picture, the ecosystem looks like, rather than focusing already on how should we implement this? Because the current, I would say, regulation for me is a mixture about having that goal and how it should look like, and also implementation. And this creates, to me, discussions, delays, which we should avoid. And we should ensure, I would say, that all aviation stakeholders are involved. We have seen this in many demonstrations. Use space, indeed, is in the current framework, a segregated piece of airspace, but we should already now take into account that there won't be only drones in that airspace, and that currently drones are limited to 120 meters above ground. This is only, I would say, a temporary limit. Yeah, we should think about the future, and then we should go to integration rather than segregation, where the current, I would say, regulation is tending to and is going to. And also maybe one thing on as the current regulation, I think, again, for me, it's of critical importance that we get that regulation. But rather than regulating, I would say, the most complex scenario where we have a fully federated implementation of the use space, I think maybe it's wiser to go in a step-by-step approach, which allows us to learn even, and to recognize the current aviation stakeholders rather than go to a fully disruptive system from the beginning. That's a bit my view on where we are with use space and how it should ideally evolve.
Thanks, Koen. I think from what you're presenting there, you're saying there is that this integration is the key because segregation isn't sustainable. I think the performance of the vehicle is changing very rapidly, and probably the distinction between a drone and what we call conventional aviation today will become very blurred. So do you think, Koen, there's something we should be learning already, taking lesson from already for how we do ATM, air traffic management today, so we don't get left with this significant difference between what use space is doing and the rest of ATM?
I do think yes, because I have learned from all the colleagues, everybody's talking, I think ATM is going towards digitalisation. Use space is per definition already digitized. I think those both should go hand in hand rather than, I would say, have them separated now from the beginning. I think this is not the good way to go into, because ultimately they will meet each other. They will meet each other, let's say, as soon as the regulation is there. And no, I think indeed, as you mentioned, they should go both go hand in hand and learn from each other.
Yeah, I think it's a very important, very good point. We had a question coming in from our audience about on use space and drones, the impact of hydrogen on the drone landscape. I'm assuming they mean hydrogen propulsion, but do you have any viewpoint on that?
I think drones, as it's put forward by AGU and by the Commission, are part of the, I would say, the Green Deal. Hydrogen, I think, is one of the most promising combustion types in drones, because I think drones, per definition, are, I would say, mainly, I would say, electrified. So I would say one of the solutions there is hydrogen, definitely. So, but that's mainly it. Let's say what I can comment on that, because I'm not the big specialist in propulsion systems.
Thanks, Koen. Just coming back to this integration, I'd like to come back to Jan Christian, because we're talking about integration and having conventional passenger aircraft in mixing seamlessly with the new drone use space entrance by transitioning between different airspaces. And how do you see the future for this, Jan Christian, from an airspace user, current airspace user point of view? What's your feeling?
Well, first of all, I like the word of integration. I think it's the right approach, but we must, as has been said by Koen, be careful in taking steps by steps. I mean, we had the situation here in Switzerland. Switzerland was very, very liberal with relation to drones, and we learned, I would say. We had some issues here in Zurich, so we are now in the state to be much more careful. And in the end, we need to convince humans who are flying with us, who are operating the plane, that everything works together. So I think these are the key points. Of course, we need to have this integration. It will come up. It's a new industry. It will do wonderful good things. I mean, we even did a test here in Zurich to use drones to get better meteorological data to predict fog. So that was something where we can benefit from. It's just a small example. It's a wonderful example. So we need to convince people, and integration, of course, is key, but do it step by step, please, and be cautious, not be too over optimistic that everything works. And in the end, I think behind every drone is a human being. Yeah? So the question is, do we connect to drones? Do we connect to human beings behind it? So it's interesting thing how we can manage that.
Thank you, Jan-Christian. Coming to airports and thinking about the problems that were faced by airports and the use of drones to create operational difficulties, I'm sure that was a headache for you at Airport de Paris, Olivier. Where do you see the role of drones? I think the airports generally are welcoming some of this, aren't they, with airport inspections and various things, and we heard about the Met as well. How do you balance this sort of threat versus benefit from an airport? How do you see it, Olivier?
Thank you for the question. In fact, the use of drones can be multiple. We can think about at the moment about taxi. We are trying to experience, VTOL, and we have we will experience that in an airport, and we want to achieve some experiments and some things for the Olympic Games in 2024. That it is very important to show that in fact we can achieve some good things and some integration, as Jan-Christian said, about this type of drones. But we can also think about using that, for example, for inspecting runways. We have already started to do that. And we can also think about having drones even within the terminal. So we are investigating a lot of things, a lot of applications to drones outside, but also inside the terminal. And I hope that it will not create more threats or more difficulties with airlines or with ATC. We are trying to work together in order to achieve, I would say, yes, an integration of all elements of ATM together.
Yep, I'm aware, thanks. Okay, yes, so thanks, Olivier. Just now really coming back, that was really useful, thanks. So just coming back to the program, the SESAR, I've got a question around the key highlights for an organization's involvement in the SESAR program. We've heard a lot about partnering, working together. But if I come to Michael, just to pick one at random, I insist it's at random. Michael, what would you say for your organization's point of view would have been a highlight for your involvement in the SESAR 2020 program?
I think I can answer that very clearly. It's about collaboration. So I think in the beginning, someone mentioned it. Working together on pan-European level means creating new innovative solutions independent of which organization, which manufacturer or operational stakeholder is involved here. And that leads me actually also to one of the points Jan-Christian mentioned in the beginning, speeding up. I think speeding up means involving the stakeholders right in time, allowing for collaboration, fostering collaboration between all stakeholders, so that the technologies we are working on are really becoming reality. And that includes not only the operational or manufacturing partners here, that includes also the political leg. So the member states in Europe need to be involved very much in order to allow for cross-border solutions.
So thanks for that, Michael. I think I see from the people I can see a lot of nods, and I think that's how we would leave this session now. We'd say if you want to achieve the digital transformation of ATM, it's not just about technology, it's not just about vision, it's about collaboration. So I'd like to thank everybody who've been participating and watching the panel, and I'd also like to thank all of our panel members, Jan-Christian, Olivier, Helmut, Michael, Csaba and Koen for their participation. I've enjoyed the panel. I hope everyone else has too, and thank you very much. If there's any questions for me, I have a short session directly after this panel where some questions can be raised directly to me. So thank you, everybody, and goodbye, and enjoy the rest of your Aero Days.
Thank you so much. Thank you so much, Peter Rottam, and thank you, gentlemen, distinguished panelists, for a great session. I think we've learned a lot. So thank you again. It's time for a short break now here in the lecture hall, but as Peter Rottam mentioned a minute ago, you can meet him now in the meet and greet area, or take a virtual walk through the exhibition hall or the partner lounge, or visit the networking area. It's all worth to see it. My dear colleague Connie will welcome you in the lecture hall again at 10:45, and then the topic will, I think, following the discussion of our first panel, the topic will be urban air mobility. So, see you then.